Hey everyone, Darwin here. Just wanted to talk to you a little bit about some of the capabilities we have in GitLab to help embedded systems teams meet some of their compliance and regulations standards that they have. There's been some new ones coming online in the last year, as well as the legacy functional safety, engineering V verification requirements, all of those kind of things. We're going to use UN 156 as a sort of a stand-in for these other standards that you might need to target. But as we go through, you can see there'll be a lot of controls right down to the capability of managing 156 RXSWIN numbers. And so as we go through this, I think you'll be able to understand the ability to use it for other things. So one of the things that I talk to embedded teams frequently about is the fact that in the legacy, embedded teams have worked at their desk frequently for the reason that hardware has to be attached to their desk. And there are some teams that might be able to move beyond this with virtualized hardware, but a lot of companies, it'll still make sense to have some of the development going on there. What has happened in the last 5 or more years is that companies have been committing themselves to providing virtualized capabilities around embedded hardware. Now, frequently, because embedded hardware does not have a lot of virtualization going on in production, so we don't have data centers of embedded hardware because it's by definition on devices that are scattered all over the world, it has taken a long time for the virtualization of these environments to be done purely for the fact of development and to speed up that development. So there's a lot of cool capabilities that are available now in automated software delivery. GitLab is able to encapsulate a lot of those for you, no matter what technologies you're using out of that ecosystem. This is an important step in the maturation of any embedded team, is to start to embrace this shared automation and to be able to use these resources to go faster and wider. One of my concerns is those teams will then, once they get the CI automation done, go back to their desks and continue to work sort of in isolated areas. And one of the challenges with that is it's not going to bring the full value of DevOps. So DevOps is really about some value promises in people, process, and technology. And this bottom green arrow is just technology, or trying to widen that funnel. Think of this as DevOps value promises of technology. And in the case of DevOps, everything's shared. So the people, process, and technology are shared aspects. If we go back to isolated development because of de facto cultural momentum, then we miss out on this very important part. And this is where we share people, or another way to say that is collaboration, as well as process. And so a couple of big effects are happening in the market. One of them is AI. So we no longer just collaborate with humans, we also collaborate with AI. Now, code gen can happen in this red box, but in the purple box, there's a lot of other types of AI interactions that can happen when you have a full and complete DevOps platform. In addition, a lot of the compliance requirements are around validated processes that are attestable, that show a chain of custody, that are validated with signatures and artifacts being signed. And that's very hard to do in an environment where you're exclusively on desktop workstations. You might need to do your initial development of desktop workstations. That might cause you to be fast. But when we start getting into the stage where we need to share more of the results, have more visibility to what work's being done, and especially when we have to start attesting our work for production releases, then moving to shared systems makes a lot more sense. And so this is where we take advantage of the value promises of DevOps around people and process, or culture. And then in process, that's our development process. Development processes include stuff like the engineering V validation, as much as it depends on software, as well as new things that are coming around like UNCRA and UN 156. In fact, let's just take a look at that. So as we talk through this, we're going to be focusing on 156, but all of these other standards and making them agile and continuous, those have to do with getting that work and that the collaboration up into a shared system. So we can see the processes being executed. We can put automated guardrails around it, even if it can't be 100% automated. We have workflow automation in order to make sure that it's as automated as it possibly can be. Here are just a few of the 156 requirements that GitLab can help address. Now, anytime you design a program that's going to meet 156, you're going to have to look at your engineering processes, your artifacts. You're going to have to make a custom program, much like functional safety. But GitLab is a rich Lego box that has a lot of options for creating a lot of controls. And so we'll see that as we go through this specific example, where some of these requirements of this specific standard are starting to be addressed through the means that we'll be showing you. So this is one kind of conceptualization of the chain of custody, so to speak, of a attested OTA process. When OTA happens, you use OTA to update your vehicles, and 156 has to do with bringing more accountability, attestation, traceability to this process. One of the key ways it does it is with the RXSWIN number, and that number is a way that we can map our software releases all the way out to production vehicles. So you're supposed to be able to see this number on production vehicles and be able to map it back into the company that made the product and the very release that made that software. This is called traceability. So the reason that we kind of burn this into the process is so that we have backward traceability into, well, hey, what if we have a particular bug in a piece of software? How do we do backward traceability and understand every vehicle that might be installed on and every piece of software that that code might be utilized in? I'm going to highlight the part where GitLab as a DevSecOps platform can play a key role in here, and that's this section here between these orange lines. And GitLab is, we call it a platform. And one thing that sometimes we don't articulate well is, what do you mean by a platform? So all these little icons here are some high-level and foundational platformed services that are built into GitLab. There's an entire separate video at the link on the screen that will take you through just in what ways does this cause GitLab to be a platform and have platform services that anyone can take advantage of. But let's do a breakdown of how they would apply to this process specifically and add value to this 156 process. So one of the things with GitLab is that we'll map in the platform here. And one of the things about using the platform is that we can start to guarantee a lot of things end to end throughout it. So the ability to enforce it, where there's a couple of things called compliance frameworks, MR policies, pipeline execution policies that all work together to enforce certain things to happen on all software development. Also, anytime you automate your software build process, you are turning it from what could be kind of team knowledge floating around in people's heads into something that's explicated, determined. So if there's some variability, like as you're explicating it and starting to automate it, you find out, oh, people don't do things the same. Well, at that point, they're going to become the same because you're going to have one automated process. That becomes shared knowledge, it becomes encoded knowledge, and it becomes automated process. So how do we build our stuff is then stored as code in the system. And so that's a really important step that sometimes we overlook is happening here. Also, it's attestable. GitLab has extensive logs it keeps, but we also have embraced something in software supply chain security called SALSA manifests that start to be able to tell you exactly what happened during software build processes. We can have it signed from the build agent on through. We can even have it so that software commits by developers are signed by the developer and are assured to be that person when they're committed. So we can even have this traceability go back and be attestable all the way back to the individual making changes. We also have the capability to do full evidence collection. And then this all also enhances reproducibility. Reproducibility is a related problem in that if you have to fix something that's 5 or 6 years old, how do you assure that when you fix that, the build process is identical so that the result is identical except for the fix? And so this also helps with all of that, being able to keep all of this information. One thing I want to note right up front here is that when we go to use this kind of process, there's a distinct difference between using a platform for shared build, shared collaboration, and shared processes, and the typical process of doing something on a workstation. Workstation builds are not the greatest for doing production releases because they might not be deterministic, they might not be explicit, they might not be shared, encoded, automated, they might not be tamper-proof, and they might not be attestable. So this is all because usually there's a human running things and keeping everything knitted together in the process. It's not automated into automation code. And so we do run across customers who are like, hey, the official build happens on so-and-so's machine, and they've got all the certificates and all the stuff. And when they get done with the build, then that's the production build. Well, this does not allow you to fit well into validated systems and into these new cybersecurity regulations. So instead, once the developer has been building and working with their environment, we want them to push it to an automated build system. Because within this build system, we can make sure things happen the same way every time, and that we have boiled everything down that's necessary into that automation code. So this is part of that shared technology value. We also want to take advantage of workflow automation that is recorded. So whether it's humans interacting and improving things, or it's machines scanning things and bringing the results back, we want all of that information and that workflow automation to be able to come back to a single place where we can review it. And so this is about the shared process piece we talked about. You can think of this purple box as the merge request inside of GitLab, where we have the single source of truth about all changes to software, all analysis of those changes, and all approvers all in one place. Then we can start to build the capability to push this to vehicles. So in this case, we're saying if we have an async component builder, then we're able to build something that can be deployed to vehicles and potentially store it in the GitLab package registry so it's ready to be deployed. And all of this is still happening within that system end to end. There's a variety of packages that can be generated, and then async has its own format, of course. And then finally, we have the capability to export. And as long as we do that export in a very attested way, so we create this manifest process according to esync's capabilities, and we drop it into an async compatible service, then we're going to have that attestation go all the way through. So basically what GitLab can add to the over-the-air story is that we can provide attestable provenance all the way back through the entire chain here, right to the individual developer if that's what's needed. This is just a picture of all of the parts. All the purple parts are really controls you have that are configurable over top of workflow automation inside of GitLab. A lot of them are human-driven, but the idea is that as much as possible, they should be automated. And when they can't be automated, they should still be as smooth and as automated as possible, which is what we call workflow automation. Over here on the very top left, you can see only signed commits and verified committers. And this is the capability I mentioned earlier to be able to test software changes right back to the individual who made them. I just show this overall so that you get a concept of all the other rich capabilities that are built in that you may or may not use. Right, so let's drop into a demo here. I'm going to take you into a repository where we have this working. The first thing I want to show you is that we have some policies set up against this repository. So we have a compliance policy framework here applied called UNCRA. Could just as easily be UN 156. We'll see that I am doing 156 jobs in here as well. But in this case, this particular policy is simply running a complete pipeline trace evidence job. So that is required. Developers who this policy is assigned to, which we can assign it right here, cannot escape these jobs from running. If they run CI, these jobs will run. They can't control them or avoid them or anything like that. And so that just helps us get one of those hooks. And we'll go back into the context of our project. One second there. And then we're going to go to a merge request. Merge requests are, like we said, the single source of truth. And I'm going to show you some details about what's going on here. So first of all, the merge request has approval capabilities, and we can establish rules and compliance rules in here. One of the ones that we have running here is that if this file RXSWIN.env changes, then we're going to have an approval made. So right now it's saying one approval from code owners is required. So we have 0 of 1. So someone has to come in and click approve. We also have it set up so that whenever anyone clicks approve, they have to re-log in to GitLab. And that essentially functions as a digital signature because we know they had to re-log in order to do that. Someone didn't just find their machine sitting there on the approval screen and click approve real quick and run out of the office. So that's another aspect of what's turned on here. So we're starting to create a chain of custody of where this RXSWIN environment file is telling us the RXSWIN number that is assigned, and we are then able to ensure that when it changes, it's approved by the official people that are supposed to approve that. So let's look at the pipelines that run. We'll dive into the last one here. First of all, this pipeline policy pre and another job at the end, pipeline policy post, are the ones that were injected by the policy that are not actually in the CI YAML for this particular project. Right here, we read the RXSWIN number out of the repository that's already sitting there. And when we read it, because it's a .env file, it makes it available to the rest of the pipeline. So from this job on, that number will be exposed. Then we also do some validation. So we make sure it's a valid RXSWIN number, that it follows the format. And then we also do something called binding, which essentially means we take that number plus the firmware version, which is separate, and we're using a separate component in order to assign the version number, the pipeline ID, and a pipeline URL link, as well as a timestamp. We put those all in a file, and that file is collected by GitLab. And so it's right here, rxswinbinding.txt. The additional thing that we do is that because we've got SALSA attestation turned on, any artifacts in this job that get uploaded get a checksum. So if I dig down into this file, we can see that that text file, which has a date timestamp in it, has this specific digest. This means that anytime we find this file that's supposedly binding these together, if it's got this digest, this exact job on this exact runner is what generated it. And so that's very helpful because it helps us understand right back to the individual runner, when did we bind this all together. And we're going to go back to our pipeline. Get unique SEM version number. It actually runs before these. It's just that this is not sorting in the right order, but get unique SEM version is part of what goes into that validation and that binding. Then when we build our software, we're actually using the version number and the RXSWIN number burned into the firmware, because one of the requirements is that you can find this on the vehicle, at least through the OBD interface, maybe there are other ways as well. So it's going to have to be in the firmware in some form. And then we have a software in the loop testing system here, which just monitors a serial port, and we're outputting that information. Then when we go down the road here, we've got some other interesting things going on. So we're creating a generic package in GitLab and a GitLab release, but also we're creating an NPM package out of it. It turns out that the NPM package manager has built-in provenance, which means that you can sign a package at the same time you are building it and putting the content in, and you can upload that signing information into a package repository. This is something that other package repositories don't have. So it might make sense for you to kind of rip off the NPM backend because of these additional provenance capabilities. This particular job then shows us the kind of commands we can run against that NPM package in order to get information out of the repository where it's stored, download it, extract its contents. And so this could also be used for customer distribution or partner or dealer distribution if it's needed. And then finally here, this last job, tagging, is going to do a git tag onto my particular commit ID. In my case, I've turned it on so that every time this job runs, it will reassign that tag. So at the end of the day, the last job to run will have tagged that last specific commit. You can also turn something off and make it so that this will not reassign the tag, which makes it then immutable. You'd have to increment the tag or change its contents every time you did a run, because you'd consider the old ones as used and already assigned to a piece of software, even if it was never released for production. We'll take a look in a minute at the results of that. And then this last job here is where we collect all the CI YAML that was used by our pipelines, all the job logs, all uploaded artifacts, including all SALSA attestations, so absolutely everything this pipeline generates, and we put it into an archive, we sign it, and then we store that as a GitLab release. So if we go down here to deploy releases, We can see that we have pipeline evidence release as well as a software release right here. And if we also take a look at our tags, we can see that our last software release, you can tell here by the commit SHA, is the same for these last three. It was tagged with the version number, it was tagged with the pipeline ID number, and then it was also tagged with our RXSWIN number. So this is the capability then to create traceability. If you see this number emitted on a vehicle, you can come back and say exactly what commit is tagged by that particular SWIN number and figure out which one is in view. So that's an example of closing the loop on the software side. We would then, which I do not have worked into this demo, take something for the OTA system like eSync and use that OTA system to export this validated, attested, signed firmware so that that can continue in the over-the-air update system to be able to target the vehicles, get the updates out, and manage all of that production deployment process. So I hope this has been helpful to help you understand how GitLab can contribute to a lot of validated flows where we have to give this attestation and traceability all the way from customer deployed technology right back into your pipelines in order that you can fix it and meet all of your software and security compliance requirements in a continuous and agile way.